She's really quick. She's got like a really good piece of so we also try to like play a game with you where she's like reading your something and she's Are you okay? Yeah. Okay. Yeah, it's the same words. Okay. I don't know. I mean, it's sort of like I mean, it's sort of like she can imply the meaning of those sentences as a way of saying it. Like her way of saying where is it? And she'll be like, you know, but you know what it means. So, and then for there it is, she'll go. So it's just like the inflection of it. So, you know, I mean, it's not like they're really. Yeah. But her language, I mean, she can say multiple things, which is fairly new.
All right. I'm good. Yep. We got one person back. Good. How's California, right? Oh, yes. I know. Yes. I know, but she's sticking around. I'm jealous.
Where are you headed?
Philadelphia.
Oh, what'd you do?
I got a postdoc at UPenn.
Oh, that's exciting.
Yeah, so I got into one of the research teaching programs. So I'll be teaching at like HBCUs and universities with underrepresented minorities. So I'm excited.
Oh, that'd be fun.
Because I've never lived in a city, so freaking out on the inside and mostly the outside as well. So, yeah.
I've only visited. I know.
I'd never been before my interviews. So, what brings you back to the area?
I'm seeing my family.
Good. That's awesome.
I will come here and see everyone else.
Yes. Oh, I'm so glad. I didn't realize you did GPP, the international program. I just got back.
Oh my god, well, I didn't even get to go. So tell me all about it. I didn't know they had it this year too.
Yes,
okay,
it was
how
like
was it?
it was amazing, but it was absolutely the most exhausting thing I've ever done.
Bet,
and no one warned us accordingly.
Yeah.
And
who went? Like who planned it?
It was a mixture of both deans. So they both went, and it was really funny seeing it, like them butt heads and everything. It was a lot of fun. But it was insane and like it was really awkward.
Jealous.
Oh, I can't believe I didn't get to go. What year were you? 2020?
2020, and then it was 2021, and then we just did everything.
So we had a couple people from 2021.
Oh, I bet. Oh, who went?
Allie and Becca, I think, was also, or in Cat. They were like the water treatment people.
Oh yeah.
I think they were the only ones from 2021.
Yeah.
But yeah.
So great that they could go.
It was insane. Yeah, it was a lot.
Yeah.
But it was beautiful. I can't wait to go back to Switzerland.
Yeah.
And like drink more wine and everything.
And I'm like, you gotta get pampered by the deans, like
yeah. Oh yeah, all the food. I have so many food pictures. It's ridiculous. But I loved like the Italian area the most. Like, just take me back. Take me back right now.
I feel like everyone says they love that area the most.
I just enjoyed eating like the gelato on the water. Like any free time we had, which was like 10 minutes every now and then.
Gelato every day.
Yeah. Right? It was like we were first train of the day, 7:30, getting done at 10 p.m. And they're like, hey, this is your free time. Go blog. None of us did. None of us did.
Yeah, no, that's so funny. Like, I went to Europe for a conference
a
couple years back, and we got gelato every single day. Like, it was our thing.
Yes. It's so good.
Get gelato.
Yes.
Right, can you turn us on?
Yes.
Distracting.
We'll talk more.
You two have a job to do. Not up here.
I don't know. Can you sit on the other side? You're on. It's not registering yours. You're muted again.
Hello. Okay, can you hear me now?
Yeah.
Let me stand over here. Okay, hi everyone. Thank you for coming to our, what month is it? June? Yes. June Science on Tap. We are really excited to talk about soil health and sustainability tonight. And we have quite the crew here to talk with you about that topic. So I have Dean Spader, who is a law practitioner turned gardening / sustainability reader and advocate. I have Dr. John Galbraith, who is a soil professor here at Virginia Tech. And we have Kaylee Heather, who is here representing the Virginia Soil Health Coalition, which is a nonprofit organization that envisions a thriving and diverse agricultural landscape in Virginia that is profitable, sustainable, and resilient now and for the future generations. So they're doing a lot of good work here in the Commonwealth. Please ask questions. We also are excited about this event because look at all the swag that we have on these tables. With that, I am just going to turn it over to our speakers and we'll make some general announcements at the end. So also a special shout out to our people on the live stream. Hello, YouTube people. If you want to be on YouTube, come stand in front of this camera for a hot second. Wave hi to our virtual audience. All right, so I will hand it over to John, Dean, and Kaylee.
Which camera is she?
Okay, she moved a little bit. There we go.
We're good. Well, thanks for coming. Glad to be here. Always love to talk about soil. I'm the reader, master gardener from the state. I gardened organically for 25 years and grew 70% of what my family ate in our garden. I come from a family of 16 children. We were raised on a farm in South Dakota, and we ate everything out of the garden. And a lot of my relatives, my family, nephews, are big farmers, small farmers, conventional farmers, and regenerative, sustainable farmers. So we have pretty healthy family debates. John's the expert, so he's going to ask for all soil questions. And JP is our producer. JP is the owner of this business. He has the experience in the field. So we may just make comments. I will start off by a quote from Abraham Lincoln, maybe Thomas Jefferson, who knows. But it basically is that we spend the first half of our life creating wealth, and we spend the second half of destroying our health to create wealth. Then we spend the second half of our life spending our wealth to regain our health. And when I read that in college, I said, oh, I better decide what I'm going to put into my body. And that's when I became interested in healthy food. So I want to ask a few questions to find out who our audience. How many of you are eaters? Raise your hand. Oh, good. So we assume you're interested in what you're sticking on your body. How many of you are gardeners? Okay. How many of you have produced over 50% of what you eat from the garden? Oh, good. How many of you are producers? There's one. So at least we have one. I tried to get, oh, are you a producer? Pasture or vegetable? Oh, sourdough bread. Wonderful. Okay. How many of you are scientists or science majors? Okay. How many of you have taken a soil science class? Okay, good. So we ought to be able to have lots of comments and so on. How many of you have heard of Gabe Brown? One? Okay, if you haven't, Google And listen, do yourself a favor. His name will be on one of the handouts I give you, along with his book. But he's sort of the legend in the field, the pioneer, just an amazing person. How many of you have heard of Drs. Elaine Ingham, Christine Jones, and my hero, Jonathan Lundgren? Okay. How many of you have heard of AMFs, or vascular mycorrhizal fungi? Okay. The amazing things we need to know about. How many of you have heard of CAFOs? What are they? Yes, concentrated animal feeding operations. 99% of the chicken that you eat comes from poultry CAFOs, and I would suspect a similar amount, unless you buy them from Sally here, of course, or the local producers. But the vast majority of beef, chicken, pork are in one of these, what I call cruel prisons. That's my view. I think if you ever get a chance, see if you can get into one. You probably will never eat that meat again if you see the conditions. How many of you are familiar with crimpers? Okay. So now let's do an exercise for about 5 or 10 minutes. This group, let's see. Why don't we get this group together? And since a lot of you raised your hands, why don't you define in as many terms as possible and write on that sheet of paper this group together, if you can get together, and define in as many terms as possible what regenerative means to you. Regenerative gardening, regenerative soil, regenerative agriculture. Just define it. And then pick someone in the group who's going to write them down and then report back to the group. Let's see. Are you participating? So we'll give you a sheet of paper. We want you to do what you understand to be conservation or sustainable agriculture. And then this group over here, and you want to join them. We want you to define in as many terms as possible the word conventional, whether it's conventional gardening, conventional farming, conventional lawns, whatever, in the purest form as possible. Okay? Understood? Okay, you got about 5 or 10 minutes. Oh, well, we'll put you two together. Both of you do conventional, and why don't you do sustainable? You have the harder part. It's in the middle. Okay, you want to get together? Is there enough seats for all of you to come over?
Live stream. 3, 4. Did they say anything?
Let me know. Oh, yeah. Okay. Well, we'll walk around and see what they're coming up to.
I sent a question here.
Conventional law already done it. It's quite a way.
There. Ask for virtual engagement. Where's your mute?
Can you turn this off while they're doing this? Just turn it down, the volume. Yeah, there. It's definitely gonna hear us
Every
now.
month we can't figure it out. Yeah, B testing. My brain What are you doing?
Trying to YouTube live.
Next week.
You the one once I move and then
I was gonna ask you, like, are you moving to PA? I lived in Philly. That's where I did my undergrad. Villanova. Yeah. I lived in like right, I don't know, a few blocks north of L, but a couple blocks in from like the center. Are you at 10? Yeah, I'm probably you're the one.
that's part of the Ivy.
Yes. It's like the frat house.
Oh, I read. I went to Penn State, so I'm supposed to Pennsylvania.
Okay. I didn't know you went to Penn State. No, first time. Okay. Right in the middle. Yeah. I don't know why I went. Almost not. It's pretty cool. It depends on where. Philly is expensive. But at least like there's things to do. I mean, like this place is expensive. I'm excited for you. So what are you going to do this week?
Yeah, so I'm
going into
coronavirus research,
You
I don't know for sure, but she also has this like sleeping virus podcast, so I was like, I like use my hands in that world, so I'm not just like the virus person now. So then I'm doing a research teaching, so I'll be teaching at the HBCU. So I'm really excited, you know, we'll like cater a curriculum to them, just like eat them for this.
That's awesome.
John taught me.
But they didn't let me do that. It was very, very strict.
Different
What
experience.
I had to do
The
was
first
specific.
semester, I'm teaching for the next 2 semesters.
Yes.
So I want to make a molecular biotechnology course where it allows you to fail and mess up and get like a week to learn everything. That's awesome.
That'd be really
It's like failing to learn something new and I can embody that.
When you
growth.
mess it up, you don't mess it up.
But it's also like to normalize the failure early on and make it a learning process rather than here it has to take this.
No, I agree. I really like that. That's awesome.
Yeah, no,
It's on a little bit better. Mine was online. Just the second semester. No, this is what you have to do. Here's your step. Like before I even taught it.
I teach genetics.
No, he like made it heartbreaking. Because like they literally like started him out and telling him like more than 50% of your class. And he's like, no, if they fail, I fail them. And then
Then 30% just don't show up. And it's like, you can't make them show up.
You want to like put your dick out here, not like awkwardly holding
Then,
them,
then sort of like
scouting out.
scouting is.
Ooh, there's like a table over there.
yeah, well,
Ooh,
he's
son.
like extra sensitive. I'm like me.
I know. I was like, I don't think I can really move this speaker system. You could like put it if you use John
There we go.
It was like that. Just don't touch it.
That's a risky job. I'm so excited. I'm excited to do fine.
I mean, they're getting ready. I was just gonna bring up.
Yes. Okay. So I got an email chain about it because I've been like, am I out of Europe? And I came back and they're like, so it's like we've got 18
Well, we're not bringing up some
We can talk about genetics and space.
I know she's not using it. I was supposed to get a coffee and then she got sick. Yeah, I talked to her. I texted her a couple hours ago. Oh, really? Talking again?
And for whatever reason,
I don't know. It's got my entire body.
I don't know.
So we have to figure out if the light goes through the camera or it goes through my computer. We have never had enough time. It's definitely picking someone up. So if you want me to be around, I don't know.
I have a microphone.
So we have wireless ones we use to like, and those are hooked up.
Okay, all right.
And I really thought, it was good as sort that's magic.
All the way. Go all the way up.
Okay, can we come back to the group? Hello? Can we come back to the group, everyone? Now, here's the hard part. Shut off your cell phones. And please, no side conversations so that we can operate as a big group now. So let's go through each group and see what they came up with. And then I'll give you a handout. And we're going to go into some more detail. Would the conventional gardening agriculture group like to report?
Hello?
We are the conventional group. Okay, sorry, we are the conventional group, conventional agricultural practices, and our list includes heavy use of pesticides, herbicides, often not integrated pest management, inorganic fertilizers, monocultures, heavy groundwater use, till farming, which contributes greatly to erosion and loss of organic matter in the soil, groundwater contamination, runoff and eutrophication of surrounding streams and lakes, soil depleting from a nutrient standpoint, and concentrated feedlots, which are incredibly resource intensive. And we've also got, let's got glare on it there. Traditional, standard, large scale, very machinery intensive agricultural practices, heavy use of fertilizers and chemicals, heavy water use, long shipping if you're not, doing a field to fork and shipping things across country, low genetic diversity, which would lead to, things being susceptible to disease, not reproducible in terms of the crops, and genetic modification of crops. So that's kind of our list.
Okay, very good. Very. My handout that I'm going to give out to you is just a quick summary from my head, and you came up with a lot of things that won't be in there. So it's good to see all the additional things you added. So let's go to the opposite end of the spectrum. Let's go to the regenerative group, and then we'll take the middle group last. So who's reporting? Okay. And keep the microphone.
Okay, can everyone hear me? Am I good? Okay, so for regenerative, we have animals in the pasture and land are followed by crops. So rotation, new life, nutrients are cycled. It looks at the whole system. There are layers of vegetation, intercrop. It's something that was damaged, but you're restoring it. The soil gets better. There's cyclical creation, working with nature and ecosystems. On the community and human scale, the whole system's wellness is taken into account. It maximizes photosynthesis. It leaves enough for the next generation, and past, present, and future are all considered, and it breaks the damaging cycles.
Okay, very good. Again, many things you won't see on my sheet, but a pretty good coverage. Now, if you're familiar with the system, we had conventional agriculture. It generally started in the 1950s, 1940s with the Green Revolution, the Haber-Bosch method that got nitrogen out of the air, and so on. And that's where it started. But then in the 1990s, about that, 1980s, farmers started with NRDS also encouraging them moving into a sustainable. And then eventually some farmers took it to regenerative. And that's where we want to focus tonight. But the sustainable ones are sort of those who are in transition from conventional to regenerative. And so they're in what I call the muddled middle, although they're not muddled. They know exactly what they're doing. And so let's get this group to, what did you come up with in terms of the sustainable?
We're sustainable. Oh, wait. Wait, I'm coming. I'm coming.
Okay. Okay, so the first word we had was net neutral, then financially stable, a balance, not profit driven, renewable, minimized disturbance, minimal input, and targeted input.
Okay, very good. Now, I'm going to give you a handout, and this is just for the purpose of trying to discuss each of these in more detail to get that distinction, because there is a regenerative, quote, revolution, we hope, taking place out there. I know it's happening when my nephew, who farms 10,000 acres in northeast Colorado, he inherited it from his grandpa and father. I called him the other day and he said, "D, I just started reading about regenerative and I've started doing it in the last 2 years." And they were conventional 100%. And so when Jeremy starts moving in that direction, something's happened. I know that. And likewise, I have a nephew in South Dakota who's been at it for about 20 years. And he's way along. I wish he were here to talk with you and tell you his experience of it. But if you could, let's see, would you want to pass these on? Would you want to pass them out? There's some over here. So as this handout is coming around, I'll basically say on the front side, we're going to talk about the characteristics. On the back side, I gave some references, which we might get to. But since it's obvious that we won't be able to cover the topic all tonight, unless John, of course, can do it. He probably can. This book came out 2 days ago, and it's on the back side. It's David Montgomery and Ann Bickley. It's I think the first reference on the back side under readable book. 2 days ago, they're scientists, 55 pages of references, scientific studies. It's very science-based. And the subtitle is what we should have named our topic tonight. It's the topic, what your food ate, how to heal our land, and reclaim our health. So they are probably the best that I have come across that make the connection between what's happening in the soil, especially the microbes in the soil, and what's happening in our microbes in our gut. Really good stuff. And it looks to me like it's a pretty good book. So since we won't get to all of that tonight, I will simply say read the book. Or do yourself a favor and watch Dave Brown or Dr. Christine Jones. Some really good YouTube videos out there. So let's start through here. Number one, we call it the Green Revolution. And does anybody know, can anyone describe what the Haber-Bosch method is that the Germans discovered? Anyone? Okay. Exactly. And to show you how fossil fuel heavy this is, I'll give a free beer to anyone who can tell me how many cubic feet of natural gas it takes to create 1 ton of urea nitrogen.
10,000.
Wrong.
20,000.
Closer.
21,000.
Closer.
25,000. You gotta get that beer.
Not yet. Anyone? You're close. Go up 8 more. 30? 33. Actually, 33,500 cubic feet of natural gas to create 1 ton of urea nitrogen. And we're dumping tons of that, especially in the Midwest, all over the Midwest. Very, very fossil fuel heavy. And that's the Haber-Bosch method. Basically, a high amount of heat, a lot of pressure to get this nitrogen out of the air. What are the other 2 sources of nitrogen? Lightning, yes. Yeah, bacteria. Nitrogen-fixing bacteria, the microbes in the typically under legumes, but I think every plant creates nitrogen. Number one under sustainable, I said it's driven by university research. Is that accurate, John?
I would say so, yeah.
Okay. And then under regenerative, I say it's driven by farmer initiatives.
Well, I would say that's largely right as well. Now, NRCS probably is pushing the sustainable line right now.
Okay.
But regenerative, yeah, I would agree, is probably driven from the individual decision makers. Yeah.
And that's where I think the farmers were ahead of the scientists. The farmers started saying, hey, this is something's happening here. We don't like it. And if you read Gabe Brown, the man is a genius. He's a North Dakota farmer, farms 5,000 acres. And he started in 1993. And if you want to read a really good in-depth story of one person, here's this book. Again, it's in the list of From Dirt to Soil. He's just a typical farmer, but he's a genius with a pot belly on the prairie. And he started doing things, and the scientists came out there and said, no, that don't work. Nope, don't work. And finally, he hooked up with some scientist, Dr. Chris Nichols from University of North Dakota. And she started testing some of the stuff to measure it, and she found out it was working. And we still don't know why entirely, but it is working, whatever he's doing. And we'll get to some of the things he's doing. So let's look at number 2. High off the farm inputs. You want to comment on that?
Okay, and that seems to be, we were talking about in the conventional group, we were talking about where materials come from. So where does your fertilizer come from? Where does a lot of the food that's sold in the grocery stores come from? You know, it's a global world, and instead of things being locally produced and locally sourced and locally grown, most of the time they're imported and maybe from halfway around the world.
Yes, in fact, my comment is we're hauling in all these tons of vegetables from California. What percent of a vegetable is water? 70%. So we're paying a lot of fossil fuel to haul water from California. You know, they have so much of it out there, you know, and we don't have much of it here. Why are we doing that? These are the types of questions that Gabe Brown asked. Why are you doing this?
A little story along that line. When I used to work up in New Hampshire, the farmers in Vermont, the dairy farmers, were in trouble because they had already exceeded the phosphorus absorption capacity of their soils. And so any more phosphorus that they added to their soils was in excess of what the soil could handle. And so if they had any erosion, then it ended up in the bottom of the farm pond or in the bottom of the stream or some other water body. And so, you know, how did they get into this situation was because of all the grain that they were importing from Iowa to feed their dairy cows. That's where the excess phosphorus was coming from.
And if you've heard of the word mining the soil, have you heard of that? Taking all of the we're slowly taking all of the trace minerals, the micronutrients out of the soil. And starting in the 1990s, my brother said they had to start adding even boron, well, sulfur, because we no longer have coal plants releasing a lot of it. But what they're starting to, I have to put in some of those micronutrients. But let's look, I want to spend more time on the right-hand side of regenerative. So this says mostly on-farm recycling, livestock essential. How many of you are vegan? Some people debate that livestock is essential, but Gabe Brown, Cedric at Weathertop Farms, they'll say you can't do it without livestock. You got to bring the livestock out of the CAFOs, out of the 100,000 cattle CAFOs, bring them back onto the farm like they were before 1950 and so on. And there's all sorts of reasons, soil reasons why. And if you want to read Gabe Brown, he says once he started getting livestock back into his pastures and into his row crops and so on, his soil, something started happening. And then the researchers had to come in and explain it, what it is. Even when it comes down to the hoops of the cattle, like the hoops of the bison, actually stimulates the plant to produce more exudates that feed the microbes in the soil. And so there are healthy soil benefits that they argue for the livestock foods. Well, let's look at number 3. I think we're all familiar with conventional biocides and so on. And sustainable farmers are doing a little bit less of each of these. If you want to see a good video, look up Rick Clark on YouTube. He's in Indiana. He farms 7,000 acres. He's a big producer, 5th generation farmer. He has moved completely away in an 8-year transition to almost regenerative, he says. And so he has, according to his chart, he has eliminated all of his inputs. And do you know how much he's saving? 7,000 acres. How much money is he saving every year on input?
$200,000.
Multiply that times 4.
$800,000.
$828,000. And he lifts them all. Well, how can that be? That runs contrary to all conventional knowledge. He's not putting on any of the biocides, herbicides, pesticides, fungicides, seed treatments, no phosphorus, no nitrogen, none of those. His diesel fuel bill has dropped 50%. Do you believe that? His passes across the land are down to 4. And so he's running his tractors on the land a whole lot less. How is he doing that? And he says, my yields are about the same. Not quite as much as his neighbors. And Gabe Brown will say, my yields, well, Gabe Brown's yields are now above the average in his county. And Gabe Brown says, I'm getting the most profit. I'm the most profitable farmer in the county. And the reason why is he no longer has hundreds of thousands of dollars in input, fertilizer, GMO seed, and so on. And instead is doing it all without any of those inputs. Do you believe it? How can you farm and get a 150 bushel yield of corn off the farm without putting something back into the soil? How can you do that? Yeah, to the north. Yeah, have you heard of Dr. Christine Jones? Do you know how she explains it? Basically, the science is, and she's a scientist from Australia, but she speaks all over the United States. She says the photosynthesis is creating, and this is carbon. Her website is called Liquid Carbon. It's creating, and there's a 4-step process. And so the photosynthesis is sending the carbon down into the soil and out through the roots. And that is how Gabe Brown and this has been measured by a company out of Vermont going to North Dakota. Gabe Brown has created 29 inches of topsoil, black topsoil. How do you do that? The soil scientists and the conventional people say it can't be done because you'd have to put on tons and tons of organic matter manure, and so on, in order to create that much topsoil. But he says, what Christine Jones says is no, the plants are doing it. If you get a high photosynthesis rate, the plants are sending this carbon down into the soil, and lo and behold, it stays there. It's the more stable carbon, according to her. And if you just stick like this here on the surface, where is the carbon going as this wood breaks down? As your leaves, so yeah, yeah, it's going, most of it's going back as CO2, back into the air. Likewise, the nitrogen. I mean, even in the 1950s, when we dumped manure on, took the manure out onto the fields, we immediately went out and tried to incorporate it into the soil because we knew that we're losing most of it. Nitrogen wants to go back to being a gas. And so trying to keep it there is one of the tricks that apparently regenerative farmers have learned. Now, I'm just reporting. You can disagree. Don't disagree with me. Just go read. But it seems like it's too good to be true. But the science is saying it isn't anymore. So that's why under number 3 on the right-hand side, Dave Brown says, I'm farming with nature. He says, just look around. The prairie that existed here didn't have any input. So how did we have 10-foot high prairies, grasses, hundreds of different forbs and so on, and really rich soil without any input? It all came from the plants. So after maybe I was creating a soil PowerPoint once, and after 100 hours of work, I came to one conclusion that I think explains it all, and that is this. Soil likes prairies, it doesn't like people. Make sense? All agriculture disrupts soil, gardening and so on. And if you want to get healthy soil, make what's above the soil as close to a prairie as possible, and you'll get rich soil. Well, we can't do that, can we? Or can we? Well, we can. Look at number 4. What is, besides no-till and low-till, what is the second most common thing that farmers are doing, either conservation or regenerative? The most popular thing that is happening. What's that? Yeah, what are you crimping? Yes, cover crops. Roots in the ground. Dave Brown says, I don't want to see a square inch of bare soil anywhere on my property at any time of the year. And you probably won't find it. Rick Clark in Indiana plants, if you listen to him, he's figuring it out. He's planting a 7-foot high cereal rye. That's becoming a very popular one among farmers. And he'll let it grow as long as possible. Because he's found that an additional 4 or 10 days increases by huge amounts the amount of nutrients, carbon and nitrogen going into the soil. And then what does he do? How do you plant corn in 7-foot high cereal rye? JP?
Use a 20,000-pound tractor.
Yeah. Yeah, run a wheel over it. Yeah. Seriously.
Use knock it over when it's mature, so it dies.
Yeah, they're called crimpers. The sustainable people, conservation ag, are terminating cover crops. Everybody realizes their value. But then the question is, how do you end them in order to plant food crops, row crops? And the answer for sustainable was Roundup. You know, you go in and you burn them down. It's called burn down. The answer for regenerative one is a crimper. You know what a crimper looks like? It's called the Chevron model. Rodell Institute has created. It's a roller that comes in at angles, and they roll it across the cereal rye, and it snaps it right at the root. So you have to do it at the right time, and it snaps it off, and it's dead. Now, what's the result of that? Right? Mulch, exactly. You are what Dave Brown calls armor on the soil. You're armoring the soil. So why don't we spend all day out in the sun like this? It's hot, isn't it? Sorry about it. There's supposed to be an awning up here. But you put bare soil in the sun like this, it is as bad for the soil as it is for your skin all day long. Not only that, but when the soil is bare and the temperature is, say, 90 degrees, the ambient temperature outside is 90 degrees, how hot will the soil be?
120.
At least, yeah, 120, 130. The soil gets real hot. And most all plants close down once the temperature gets to, what, 80? Done?
When does photosynthesis stop?
Yeah.
That I'm not sure of.
About that. It slows down.
Yeah, we need an or a botany person. But hot soil, hot bare soil is not good for the soil and it's not good for the plants. So what is Rick Clark, Dave Brown doing? Dave Brown has gone so far that he has 75 different cover crops on his 2,500 acres of row crops. And also now he's putting them in his garden, in his pasture. He has 2,500 acres of pasture also. And so the addition of these to the soil is what he wants to do. He wants to get as many different plants, like a prairie. How many species of plants were in the original prairie?
Thousands and thousands.
Yeah, thousands.
Many
literally.
thousands of thousands.
Yeah. And how many insects were around?
Same answer.
Exactly. And Jonathan Lundgren, my hero, is an entomologist from the, he works in the South Dakota Agricultural Research Center. He got a presidential award for being a top scientist in the USDA. He got it in the White House. Okay. And he started saying 99% of all these insects are beneficial. Stop poisoning them. The 1% we will control by the 99% that are beneficial. And the research kind of shows that, if you want. Well, I got the high sign. How are we doing for time? 6:30. Okay. We have, okay. So number 5 is polycrops. Instead of monocrops, we want polycrops. Instead of monocrop lawns, you're going to go home and plant a prairie lawn, right? All natural plants and so on. They call them cocktails. depending upon what you want done with your soil, farmers are beginning to find out through experience, and researchers, the scientists are helping them. I think there are thousands of research studies going on now on cover crops because they become that important. And then we all know about compaction and so on. So water, how many of you have heard of a soil, what's the term for seeking water? Respiration, soil transpiration, for how fast water will infiltration. You want to explain that?
Infiltration is just an idea or concept of how fast water moves into the soil. And so that is affected by structure and texture. So a sandy texture, you're going to get very high infiltration rates, very low runoff. If you have loamy and clayey textures with good structure, you're going to get high infiltration rates and low runoff. You get loamy and clayey textures with poor soil structure, or worse yet, crusts on the surface, and you're going to get extremely low infiltration, extremely high runoff, and erosion.
And so what Dave Brown has found with his North Dakota soils is that, well, he said fortunately, NRCS came out in 1994 when he started farming the farm, his wife's parents' farm. The infiltration rate they found was 1/2 inch per hour. Think about that. The fastest the water would go into his soil was 1/2 inch an hour. So you got an inch rain, half of the water left the land. And so a regenerative farmer, if you ask them the question, how much rain did you get? You know what their answer will be? Yeah, all of it, exactly. Because now, Dave Brown, here 25 years later, they do tests. His soil, if you put an inch of water in this little infiltration, the soil will absorb it in 4 seconds. No, 7 seconds. And they put another inch in, it'll absorb the second inch within 25 seconds. That's how fast. He got 11-inch rain one year. I think it was about 3 or 4 years ago. All of it soaked in. All of it. The neighbor, and he's got pictures of it, across the road, had ponds all over the place. Ponds. So if you see water on the soil after an inch or 2 of rain, that soil is being mismanaged. They're not managing that correctly. So a lot of, I submit that a lot of the floods are being caused by the way we manage soil. We could prevent a lot of the floods by just managing the soil better. Okay. Well, let's see. I want to cover this one. AMF. You want to know about arbuscular mycorrhizal fungi. Now, those of you who are Latin scholars, tell me what arbuscular means. No Latin scholars? Well, I figured this out because I took Latin in high school. Arbor, for Arbor Day, you know what arbor means? Tree. So arbuscular means tree-like. These fungi that go out 10, 15 feet into the soil around the plant with their hyphae, the mycelium, come back into the root, and they go right into a root. And inside the root, the new technology shows us is a tree-like structure. So what is happening with the plant and the fungus? But yes, not only communicating, the plant is bringing food to the, I'm sorry, the fungus is bringing food to the plant. Phosphorus is one of the big ones. That's why farmers in the Midwest say, why did we kill all of our EMFs? They're trying to get them back because the phosphorus is out there. They just don't have a way. The microbes will bring them back. The fungi will bring it back. And what is the plant doing for the fungi? What? Yeah. Fungus cannot support itself. Fungus does not photosynthesize. So the plant creates carbohydrates and sugars and says, hey, here's some fast food. And the fungus says, oh, thanks, here's some phosphorus. And then there are a lot of other things, amino acids, enzymes, and they're finding all sorts of things. The interaction of the microbes with the plant. Microbiology and the study of the biology of the soil is what's revolutionizing the ag community. We are finding with the new technology, and as I understand it, within the last 10, 20 years, because we didn't have this technology before, and now we have gotten it. So studying the biology, the chemistry, and the physics of the soil, personally, I want to study more of the biology. So, Marie? Oh, I'm sorry. Yeah, any questions? Yes.
What kind of ag practices am I using? What kind of ag regenerative practices am I using? So a lot of these ag regenerative are based on big ag, corn, soybeans. With a vegetable farm, we're pretty high input, high turnover. Okay, I'll try. Well, I would say our fertility is pretty unique. So we do a diverse of crops and a diverse of animals. So we are using cover crops primarily in the off season. We're using a lot of mulch. We're bringing in mulch. We're not buying compost because we think buying compost is essentially trucking a lot of water. But we're getting a free source of mulch delivered as a waste resource. So we're taking that. We are purchasing organic feed. So, for our animals, which are grain based. So you can't really love that idea, but we do. Let's see, what else are we doing that's regenerative? We're moving all of our animals every, week to 3 weeks, depending on the season. We have several no-till plots, so we have a roll crimped plot as well, small, but we have way more no-till, which is, I would say, human powered. We use machines to move the mulches, diesel fuel at this point. We do have an electric machine as well, and those are our best plots. Honestly, it's the no-till plots that are just layering on mulch. What kind of mulch? We use anything from asphalt shingles. It's probably better than nothing, but primarily leaves. We started our farm in town limits because I knew there was a huge resource of free town leaves, and we have kind of ran on that free resource to jumpstart us. So with regenerative, you got to kind of create it all yourself on site. You can't really be trucking the leaves, to Floyd County even, So, but it just kind of jumpstarts you and gets you going. We do what's very specific is our nutrient management plan. It's very heavy biology based. It's not the typical organic farm where you're just putting in, 822 5-4-3 and just like dumping it in because it's a cheap insurance. You know, fertilizer's cheap in some ways. But we're doing something called sap testing. So we are sending sap tests of certain plants off to a lab. There happens to be, this is the non-sustainable part. There's one lab in the world. It's in Holland, the country. And essentially the soil test is what's in the soil, not in the plant necessarily. Then there's tissue test, which is in the plant, but 6 weeks ago. And then there's something called sap test, which is like the blood of the plant. And that's the most accurate up to date. From there, we're putting in those very specific nutrients to balance the soil, essentially the plant, to balance the plant. So for instance, we needed nitrogen in our early tomatoes, being it was early in the season, but we had to add molybdenum, whatever that is, not nitrogen, okay, to unlock it. So those are the kind of things that we're doing. Looks like everyone's leaving on my talk. So does that make some sense? That I probably missed a few things, but
Okay, the question is, are there nutritional differences between regenerative and conventional food? Maria, you're the nutrition major. I would say they report on lots and lots of studies in health. I could read a part, but I think it'd be best just to refer you. You want to?
No, I'm not really qualified to answer that question, but you can look it up. There's a lot of people doing really good research on it. And if you want to come talk to me after, I can give you some resources, but I don't want to stand here and take one side or the other because I don't know enough.
I think the best resource for the nutrient density is the Bionutrient Food Association. I think I don't know where they're exactly located in what state, but they're in the Northeast. I think you'll find a lot of information from there, what they're going forward with. Essentially, they're making this spectrometer, you know, it kind of tells you what's in the product. It's the same technology that tells you the mineralization on Mars. So,
Is that Dan Kittredge?
Dan Kittredge, yeah. So that's a great resource, and follow them. I think it's going to be in your smartphone one day. It's going to cost you another 7.5 cents to get it. So iPhone won't do it, but Android will. So ready for that expense in your phone.
Any other questions? Okay.
I was just curious because you mentioned some farmers that were transitioning from one end of the spectrum to the regenerative end of the spectrum. And I was curious, you mentioned that one farmer did it in 8 years, but I was curious if there was like a time frame that people are able to kind of do that switch over.
Well, Rick Clark said he did most of it in 4 years, but because he had a lot of happy accidents, Mother Nature, as he said, forced him to do it. One spring it rained, and he had to plant his corn or not get it in. So he went out with his air drill, which, as I understand, is shoot stuff. So he crimped it and shot it in, and he realized, my goodness, I can do this. This works. And so he found out that he didn't have to terminate his cover crop a month or 2 months ahead of time. And he didn't have to strip till it. He could actually, I don't know. But he said he did most of it in 4 years. But the fine tuning, and that's where a lot of the learning and the experience and the courage to do it comes from the farmer. And I hope you appreciate JP and all people who produce your food, because these folks are really the ones who are doing it on the ground. And I'm quite convinced their food is very nutrient dense. But hopefully someday we'll be able to make it.
So we have time for one more question, and it is from our online audience. It's for JP. They are curious what animals are raised here and what vegetables are grown and what kind of synergy goes on between the two.
Okay. The question is, what do we raise? Well, we don't raise sweet corn and we don't raise pumpkins. Yeah. And why? Economics. We animals. There's beef cows. There's pork, which are called pigs. There's chickens for meat and eggs. There's ducks for meat and eggs. There's turkeys. Geese. It's just so fun. Those animals kind of rotate through cover crop fields or are just kind of getting out of the nets. But we typically keep our intensive vegetables separate in different plots. We will clear out the beddings, compost them with a loader, and then apply those to our intensive fields. For vegetables, like I said, we don't raise sweet corn. We don't raise pumpkins. There are things we fail at every year. So onions was last year, so we didn't raise onions. We do it, yeah. So big crops: tomatoes, lettuce, peppers, cucumbers, summer squashes. You know, all the green bunch greens. That's arugula. I mean, it's going to be chard. A couple kinds of kale, collards, leaf broccoli. I mean, how you guys want to hear me say everything? Yeah, it's yeah. Yeah, is that enough? Did that cover it? Yeah.
Okay.
Yeah, it's.
Okay, we want to have a couple people. Haley, would you want to talk about For the Soil?
Sweet. So for people who don't know, the For the Soil is a campaign run through the Virginia Soil Health Coalition. So it's a nonprofit. The beautiful thing about soil, we've talked a lot about it on an agriculture scale. Like you look around, there's soil all around you. And where the grant and the money coming from that supports the Virginia Soil Health Coalition and the For the Soil campaign is actually has to do with the watershed implementation plan. Virginia has beautiful waterways and an incredible Chesapeake Bay that unfortunately has been getting polluted and experiencing a lot of poor water quality coming into it. And something that's really cool about soil is that not only will you see improvements in food nutrition, like health, growing, production, but you'll also see better ecosystems, cleaner water, like better quality of water running off, less water running off. So there's a lot of these co-benefits that you don't really necessarily see when you just look at a plot of dirt or a plot of soil. So there's so much, and we've talked a lot about farming, but half of the coalition is targeted towards farming and the other half is targeted towards urban areas. Recently in Virginia, there's been a steady increase in improving runoff from farms because when you think about it, like farmers know what they're putting on their land. They know how much inputs they need, and it's a business, so they don't want to go, there's like this misinformation or this representation that farmers are like going out and just dumping urea all over. Like that's not sustainable as a business, and they're dealing with so much more land. And so over the years, a lot of this has gotten better. This knowledge has become more accessible. People have been implementing it, and there's been a decrease in runoff from agriculture. However, urban runoff has remained at the same rate in Virginia and hasn't been improving because it's easy to kind of point the finger, oh, it's over there, oh, it's over here, and everyone's dealing with a lot smaller scale. When you have a quarter of an acre of land, it's a lot easier to dump a whole bag of fertilizer and just be like, oh, my lawn will be green next week, and not necessarily thinking about it. So we want to promote things like planting native plants because not only are you improving the soil, they last better, they have less inputs, but you're also increasing like habitat for pollinators and habitat for local wildlife. And then looking at different things such as just like managing your fertilizer inputs, actually testing your soil, and just knowing more about your land because it's easy to forget about it in an urban environment. And there's a lot of programs from different companies like the Virginia Soil Water Conservation Districts. They do, they have a cost share program that I have a little brochure. It might be all out, but it'll be online. And it talks about the cost share opportunities for native plants, for reducing permeable surfaces, for planting rain gardens. Rain gardens are now a huge thing, like contour landscaping and how to landscape based on what your land looks like instead of trying to force an ecosystem on the land, what comes naturally. And so there's so many steps going forward and there's so much action. And the purpose of the coalition and the For the Soil campaign is to help get people those resources and to help get people excited about caring for the soil and that you can have an impact too. Like only having a quarter of an acre kind of seems like you're not really going to do much. That's a quarter of an acre. You could be supporting pollinator habitat, that you could be reducing runoff. So like it takes an army, it takes a nation, it takes a world. And there is something you can do, whether it's support farmers like JP and Sally who are being conscientious and trying new things and constantly improving and finding what works and finding what didn't and being smart about it. And then there's also stuff you can do personally. So we have some swag. We are on the vasoilhealth.org, forthesoil.org. We have events, we have resources. Don't be afraid to reach out. I can give my email. People want it. We have a pledge sign up right here on these little sheets where you can put your email address and you can receive bi-weekly newsletters. Just don't be afraid to take soil health into your own hands. Everyone can be a soil steward. It doesn't have to be just farmers. And, you know, don't be afraid to ask questions. So that's all I have.
Okay. Thank you, Haley.
Yeah, so we're for the soil. Sorry, I guess that's the important part. For the 4 main principles of soil health, there's keeping the soil covered, like we've talked a lot. Don't want to have bare soil because, you know, soil likes to do things. If it's bare, it's like exposed to the sun. You're not doing anything for the microbes. You're not doing anything for the wildlife. And then keeping soil covered. So you want to have diversity or energize with diversity, having livestock, having different plants, having native plants. Minimizing disturbance. So we talk a lot about that with like reducing inputs, like outside inputs, like be smart about your fertilizer. And then it also goes into like no-till, less compaction. And then so reduce bare soil, keep soil covered, maximize living roots. So it goes back to that keeping living roots in the ground. You know, the mycorrhizal fungi provides such like this beautiful symbiotic relationship. But what do they do if they're not receiving any food? And then where are they giving these nutrients that they're pulling out of the soil? So it's all just a relationship. Everything was living and surviving before people showed up. So it's important to refacilitate that and like become a part of the system rather than removed from the system. And then we have stickers and bookmarks and all of that in more simple terms.
Okay, hope you're very, very successful. Okay, and then John is doing a wonderful thing. Yeah, thank you, Chris. Has a wonderful project, and I thought we ought to give him time. It's actually providing food and so on. You want to talk about it, John?
Okay, we have an organization, a cluster of a few volunteers, very few, about 7 to 12 of us, and we grow food and donate it to food banks. And I've learned a lot and gotten a lot of help from JP and Sally and Dean as well. And what we do, we have a 3-pronged approach. So we glean food, which means that we go out into, if we can find producers that will give us permission, then we go out and we do a second harvest. So in other words, after they've taken their harvest out, we'll ask them, is there anything left? And if there is, if they allow us to come out, it's called gleaning, and we come out and pick and salvage harvest anything that's still edible. Sometimes it's a little bit low on quality. Sometimes it's a little bit over mature. Sometimes it's has bug holes in it, but it's food. It's usable food. So we take that to food banks as well. And then we also purchase food. We buy 3 18-wheelers full of potatoes every year. So, and we do that. The farmers in Maine Wisconsin, Minnesota donate potatoes, they get a tax write-off by donating, and they donate what's called seconds. So this is not the beautiful potatoes that you're going to get in the grocery store and pay 75 cents a pound for. This is potatoes that I pay between 3.5 and 8 cents a pound for. They're perfect. They're just too small, too big, have too many bumps on them, might be shaped funny. Some of them look like the Pope, but they're perfect potatoes. So altogether, we put about 150,000 pounds of food into the food banks in this region, plus San Antonio, Texas. We branched out there because that's my hometown. But we got a little frustrated because there's no diversity around here. Tell me what vegetable crops you see. If you have to close your eyes, because right over there is lots of vegetables. But once you get away from a CSA in this part of the world, can you tell me what the major vegetable crops are? 99% is field corn. That's not for humans. There's two or three sweet corn farmers. Pumpkins. How many people eat pumpkins? Raise your hand if you eat pumpkins. Oh, don't be shy. Come on. All right. Yeah. So what was that? A percentage? Less than 10%. So maybe 5% of this audience, which I would say is probably higher than if you just went out into the general public. So, let's say 1 to 5% of the general public even knows that you eat pumpkin. You don't just decorate it and then shoot it out in a slingshot or use it for target practice. But yeah, so pumpkins are bred for decorations, and they are very low. They're not that nutritious. They're very fibrous. We got frustrated because there's no diversity in the crops. Who's growing cabbages around here? Who raises potatoes? How many people grow tomatoes? How many farmers grow tomatoes? Not the CSAs, but other farmers. Who's growing other nutritious foods? Nobody. So I'm frustrated by that. But there's a couple of farmers in the region, and we drive out to those farmers, and we do get sweet corn. We do get turnips. We do get winter squash, and we take those to food banks as well. But we got frustrated because there was no diversity of crops. So that's why we started growing our own. And also because we had some control over the production. And when you're completely reliant on somebody else to give you their leftovers, you're completely at their mercy. You have no control over anything. And so we wanted some control. We also wanted to extend the season that we could grow, and we wanted more diversity than just sweet corn and turnips. So and so last year we grew, JP, you'd be proud of us. We grew 12,000 pounds of vegetables and 17,220 pounds of winter squash. And all of that went to food banks. So if any of you would like to get involved, come up and see me after the talk, and I'd be glad to tell you more.
Okay. And then Maria, you have a couple.
Thank you so much to all of our speakers and For the Soil for being here. We are right at time, and Rising Silo does have live music for you tonight, so just head over to the other side of the barn when we're done here. Science on Tap, we do want to thank Dr. Nicole Bracci, who is leaving us. She's been one of our co-organizers for the past year plus. Yeah, new PhD over there, just defended her dissertation, and she is heading to Philadelphia. And we also want to bring on to the team Amy Hagan, who is over under the umbrella. So come check us out. Our next event is in July, 4th Wednesday, I think the 27th. And we are going to have live reptiles out here. So make sure you come check us out for that one. Like us on Facebook, sign up for our email list over there on the clipboard. And if you are so inclined, throw us a couple dollars so we can keep these events going. Thank you again to our organizers and our speakers. And stick around for some music. Please tip your bartenders. Thanks, everyone.
Thanks, Maria.
Thank you, guys. Thank you.